TO is congruent to AN. So TO, we don't know what it is. We don't actually know what exactly it looks like, but there's T, there's O. I would actually require you guys to draw a picture on this. I think that's super helpful here. So we're saying the two line segments are congruent. And that is what you're saying here down here. Uh, you're saying that that the it's like if they're congruent, that means that they are the same length, which sounds weird. It's like, why do you have to say that? But that's geometry. You have to, congruence is not the same as the same length or the same measure. All right.
So would the conclusion be different?
Well, no, the conclusion is correct. The justification is not correct. It's a definition of, or it's something like congruent segments have the same length. It has nothing to do with angles.
Mm, okay.
So it could be like definition of congruent angles, or like these words here, congruent segments have the same length, things like that. But the picture is really helpful. Like I would definitely recommend, you see how like 8, 9, and 10 have a picture. I would recommend some sort of a picture there. So, all right, given E is the midpoint of BD. So let's draw B and then D. Okay. If E is the midpoint of BD, that means that BE is congruent to BD. That's very, very good there. Definition of a midpoint, that's completely correct. Perfect.
Okay.
All right. And then 3 also looks really good here. You've got kind of got a for there, which I like. That's always a good thing. So CT, there's CT, there's A bisects it. Bisects means it cuts in half. Definition of a segment bisector. Your conclusion, I'm not really sure exactly what your instructor wants here. Yeah, the line segments are congruent. This is probably not needed, and same with this one back here, probably not needed, but I don't know what you guys are doing in class, so the
I just added the last part because it was on one of the things, but I guess I was kind of confused on why we had to add it too. So,
it's kind of like this if A bisects CT, then the conclusion, then CA is congruent to AT.
um,
All right, so this looks fine to me. So number 4, let's take a look at number 4 here. So one of the things you're missing here is the line segment above those. You'll notice that if they're the same length or the same measure, that's what this is saying up here. Therefore, they are congruent. But congruence only refers to line segments. So you have to have that little line above there. And then it's nothing to do with angles. I'm not quite sure where that's coming from. Maybe you're just thinking of angles or something when you're working through this, but it's definition of congruent segments.
okay, yeah, that makes sense.
All right, so on to some new stuff here. All right, so angle DAY and YAK are linear there. Okay, so you got to look for the overlapping letters. That's important there. So let's draw a straight line. There's a straight line, and we're going to make something like this. So D to A to Y. That's the first angle. I've just arbitrarily chosen that. But the letters that overlap have to be on the angle part here that they share. And then YAK is there. Okay, so what can you say about a linear pair? What's kind of the big thing if two angles make a linear pair? Do you recall from class?
Linear pair.
And
Would
it's
they
okay if you don't. That's what I'm here for, is to help, but I'm just asking if you got it from class.
would they be like supplementary?
Yes. So they add the measure of angle DAY plus the measure of angle YAK equals 180 degrees. Justification is the definition of a linear pair. You will often see that that is the direction these things go.
Could you also say definition of supplementary?
No, no, because it doesn't say that they're supplementary. That is true. Um, Typically it's the definition of whatever it um, is what you're allowed to use. You can't kind of switch the words. They're not necessarily interchangeable, even though we kind of think of them as being interchangeable.
Okay. Hmm, okay, that makes sense.
Right. So the next one is where you're kind of going with this thought process. So 6 here. Yeah, and I would recommend uh I would recommend trying to draw something. The problem with this one is that they don't like match up. So they're just two generic angles. It's like, all right, there's Tom, POM, and then there's Sue, SUE, but they're not necessarily like in the same, excuse me, they're not necessarily in the same like line. They don't share any letters. If they did share letters, you'd want to draw it slightly differently. Okay, so you just answered it though. If they're supplementary, what do we know about them?
That they're linear.
Say that one more time.
That they're linear.
Yeah, they add up to 180 degrees. And this one would be the definition of supplementary angles.
So this one would be supplementary angles.
Because it says supplement. Like you have to use what's given there. You can't make something up, even though it sounds right. Like this one says linear pair, so it's definition of a linear pair.
Mhm.
This one is supplement. That means that they add up to 180.
Oh, okay. Okay.
Any questions, thoughts on that?
No, I think I get that part.
All right. So number 7 has a picture, which I guess that's nice. I wish they'd give you a little more. Given this, it's clear they want you to say something about angle 6 and angle 5. The thing is that you're not really given that you should be given here. You'd be told that MS is a line. It is a line, but like, like we're supposed to presume that this is a line here, which means that it's a straight angle, which means it's 180 degrees. So I think you can either say that angle 6 and angle 5 make a linear pair. That would be one way to go. The other way to go here is to, like, the second option is to say that the measure of angle 6 plus the measure of angle 5 equals 180. That would also be good to say. Like, either of these are good conclusions. Now, did your teacher say you could have more than one conclusion?
Um, she didn't really say anything about that.
Well, I'll just kind of throw out all the things that I think that it could be here, that you might think that it could be. But when you see a straight line like this, a straight angle, you're either going to be linear pair or supplementary. Those are your most likely options.
Mhm.
And so your justification depends on which one you're doing. It would be definition of linear pair, or it would be definition of supplementary angles.
Wait, so how come this one is can be both?
Well, because I don't know, I don't know what they're trying to imply here. I just don't know. You
Oh,
could also make an argument that they don't want you to use the numbers. They want you to use the letters. Like, you could change it up like that. Measure, you could say like the measure of angle MUT and the measure of angle PUS. Like, instead of 5 and 6, you can refer to the angles by letters.
huh. Okay.
Right. Um, I mean, that's a question for your teacher, really. Like, remember, I'm coming from this as like, I don't really know, and like these are my best guesses based on what I'm seeing. Did you guys talk about converse though? I guess I should ask about that. Did you talk about a converse today? Yeah.
Converse?
Converse, yeah. Not to use the convert though.
No, we didn't talk
Okay,
about it.
all right. Let's go to number. All right, why don't you tell me what you see? I've done a couple here in a row. What do you see on this one? What stands out to you?
90-degree angle.
Yes. So 90-degree angle means the angles are complementary, but I think for this one, they want you to say that the two angles, angle 5 and angle 7, maybe we just say it that way. Angle 5 and angle 7 are complementary angles. And that leads to, I mean, that leads to the fact that they add up to 90 degrees. But I think for here, you can only say that they are complementary. And your justification is, again, definition of complementary angles. You should detect a pattern that you tend to reuse that over and over again, that definition of.
Okay.
For number 9, is the drawing missing something?
Mm,
Like, maybe does your scan have like lines showing congruence? Anything like that?
no.
Well, I don't know what we can do. Like all we know is these are 3 points, two line segments. I mean, we don't even know if F is, we don't know anything about F. We don't know if F is the midpoint, which is kind of what I think it's going to. Is there anything else here for number 9?
No.
Okay. Well, yeah. Like I said, I think I'm trying to make a guess here. My guess is they want you to say something like EF is congruent to FG. And that's why I think we're missing something there. I'm not sure though. The justification would be that F is the midpoint of EG. Now, this is where this whole converse thing keeps coming into play, and that's why I've asked, I asked you in that previous problem, because this is really a converse thing. And it, do you know if you're in that section of the book, maybe?
I think I am, but we probably haven't gone over it.
Okay. So that's maybe, and this is due tomorrow?
Just this page, yeah.
This is page, okay. So this might be something to like ask your teacher, you know, before you submit this, especially if it's graded, because I don't know if that's the direction they're going here. But
Mm.
we can talk about it if you would like.
Sure.
Okay. So here is what, so let's back up here. If I tell you, that F is the midpoint. If I tell you F is the midpoint, that leads to, in this drawing, EF is congruent to FG. And the reason is the definition of midpoint. Okay. So you're starting here and you're ending here. Now, the way the converse works is if you start here, like let's say that EF is congruent to FG, like they just tell you that, like I keep kind of saying here, like EF is congruent to FG. Well, then then going to the other direction means that F is the midpoint. You're going from this direction now, and when you go backwards, it's called the converse.
So when you go backwards, it's called converse.
Yes, yes. So the justification is so that's where if what really should probably be happening here is this is given that they're congruent. The conclusion is that F is the midpoint, and the justification is the converse of the definition of the midpoint. But again, I like 3 points doesn't give me enough to go off of, and we got the same problem in 10. So trying to, I don't know. Sometimes I'm at a loss with what I see students being given. All right, so give me like just 30 seconds here. Gonna deal with a hungry cat, and then I'll be right back with you.
Okay.
All right. Any thoughts on that before we proceed to 10?
Mm. So how would you like how would you notice when a problem is converse or converse?
Yeah, that's a really important question to ask because it's easy to use the wrong thing. That it's the whole like if then if it's a midpoint, then it leads to that. So if you're starting with the conclusion and going backwards, that's when you know to use the the converse. So is this thing the conclusion or the like the end result? So sometimes you need a simpler example, like if it's cloudy, then it rains. So your conclusion is that it rains.
Yeah.
Okay. So if you show up somewhere and it's raining, you know that it must be cloudy by the converse of like definition of clouds in the sky.
Oh, okay.
Okay. You know, if you, I don't know, let me think of another, I don't know, I'm trying to think of, I don't know anything about you. If I knew, do you have any, do you play any sports, any clubs, activities?
Um, I dance some in choir.
Choir, dance, choir. Okay, these are striking out here. I don't know much about dance and choir. Okay, if you sing a great song, the crowd will applaud. Okay. And so if I show up and the crowd is applauding, what do I know has happened? You you must have sung a great song, and that's the converse. But
Okay.
but going forward is just the definition. It's like definition of I'm going to sing a great song, then what's going to happen? Well, people are going to applaud because you're really good. But if I only know that people are applauding, clapping, then to know that you sung a great song, it's the converse of it.
So could it kind of be like similar to like cause and effect, kind of?
Yes,
Okay.
exactly. Exactly. Now, these aren't the pure math definitions, so like your teacher may not like it, but for learning, I think it's very good what we're doing here. So let's just say that we started out by knowing that this was a 90-degree angle. Let's say we knew that from the moment. What would we and we're going to work this backwards. If this was a 90-degree angle, then what do you know about the two angles?
That they're complementary.
They're complementary. So angle FED and angle DEG are complementary. So that's the effect. The cause is that it's this right here. That's the cause. Okay. So what I'm sort of suggesting here is that there's some missing information. Like you're supposed to have been told somewhere that like these angles are complementary, which leads to angle FEG is a right angle. Or FE, yeah, FEG is right angle. Um, so if it is a right angle, then we know that they're complementary. I'm sort of saying that we're supposed to assume that they're complementary.
Um,
So when you go backwards here, it's a converse. So it's converse of definition of right angle or complementary angles. We don't really know. Like we don't know enough here to be able to do.
yeah. Okay. Yeah, that makes sense. I think the cause and effect strategy helped.
Okay, great. You got to find what's going to make sense to you. Like that's really important. Um, all right, so we're going to go to 11 next.
Okay.
Let me snip that in. All right, given measure of angle ABC equals measure angle of HIJ. So uh, all we know is there's two angles, A, B, and C, H, I, and J, and they have the same measure. So if that's like 60 degrees, then that's 60 degrees. So if they have the same measure, what can we say about the two angles if they have the same measure?
Um, if they have the same measure, then they're congruent.
Then they're congruent, yes. And it's really odd. It's really odd that you have to say this, but that's what you have to do in geometry. So measure of angle ABC, measure of angle HIJ. The angles are congruent. So normally you're given that the angles are congruent and that they're the same measure. Now, since we're going backwards, it's a converse of definition of congruent angle. So if you go back to like problem, I guess we didn't do any of those, but normally it's that congruence leads to same measure. So when you go backwards, it's the converse. If you're told they're the same measure for congruence, that's converse.
Okay.
Thoughts on that?
No, it makes sense.
Okay. All right. 12. 12 here. It just never end. All right. This is actually good. This is actually really good to do. I've not seen it done this way in a while. This is a really good way to do it to learn. Um, cat and wrap are vertical angles. Now, vertical angles share a vertex, which means they share a letter. Okay, so and you typically draw vertical angles as an X. That's A. So we got CAT RAE. Or your drawing could look little different, but be sure to have something down. Now, vertical angles are congruent. That's like and if you've been situations where you finish each other's sentences, like that's how you got to be. Be like, all right, vertical angles they're congruent. You're able to finish that sentence. Lots of definitions in geometry that you have to remember. So if you like note cards or Quizlets, like I would do something to just build these up and spend 5 minutes a day looking at them. So that is the conclusion. The conclusion is that vertical angles are congruent. We're just saying that the angles are vertical angles, so the conclusion is that they are congruent. Angle cat is congruent to angle rat. Cat and rat. Oh, that's terrible. Okay. What do you think the justification is for that?
Um,
Definition of what?
Vertical angles.
Yes, yes. It is that simple. It really is. Okay. This is the cause and this is the effect. Now it works in reverse. Like let's just say they gave you this picture and they told you that this angle wrap is congruent to this angle cat. You would know that they're vertical angles by the converse of the definition of vertical angles. Questions, thoughts on that?
No.
Okay. All right. Given angle SAT is congruent to ACT. As a side note, I do SAT, ACT test prep if you're ever interested in that. I got like 12 thousands of questions that we can go through and classes and stuff like that. Um, they're just saying the angles are congruent. That's it. Like you don't have to draw them next to each other. It's just that S, A, and T and A, CT. We just know that they are congruent. We wrote this earlier. What does congruence lead to?
Congruent. The same length and measure.
Same length, same measure. Check which word. In this case, it's measure or angle measure. Usually measure is the more official word, which means that the measure of angle SAT equals the measure of angle ACT. And so keep in mind this congruence, this kind of like equal sign with a little twiddle above it, that is only for congruence. The equal sign is only for measure. If you mix them, that is considered wrong. I don't know, it's like if you're learning Spanish, being one letter off is like in a lot of situations, false cognitos and stuff like that. Uh, it's like that. It's really specific in geometry. Okay, so the definition of what are these things? They're congruent angles. There's not as much mystery as you would think. It literally is. It's always kind of more literal. It's like, what is it? Well, they're congruent angles. So definition of more times than not, you'll be right if you do that.
Okay. Um, okay. And is there specific justifications that we have to do, or can it just be like anything that we see?
I have no idea. The there's only so many reasonable ones, but like you could, if you that's what I was referring to, like you could, if you made the right picture, potentially have something else here. But like this is the most like likely one that they want. Uh, it yeah, they probably only are only looking for this one, but like if you told me, I don't know, yeah, let's just leave it at that. I don't want to get, we're probably going to make it more confusing. Yeah, they're only looking for one answer in these.
Okay.
Okay, next question, last one here on the page. Given A is in the interior of angle GLD, so there is GLD. Now, one thing you probably have noticed me doing tonight is I'm drawing the angles like always the same. You really want to get in the habit of always drawing things the same for consistency. You'll do this again when you draw triangles. You want to always draw them the same. If you start drawing parallelograms, just keep drawing them the same. Don't mix it up. It will get confusing. So A is in the interior. There's A, yay. All right. So the only thing we can say here is that there is now two angles. And what do we know about the two angles relative to the big one?
What do you mean?
And that actually does, maybe will change what we did in a previous problem, but then it's okay. So what our conclusion here is that measure of angle BLA plus the measure of angle ALG, basically this first one plus the second one equals the measure of the big one. And actually, we will go back and change 9. Now I know what they want in 9. Maybe that is what they wanted in 10. Okay. I'm starting to see what they want here. Okay. So just generally, like, what do you see here in what I've written? What words, keywords come to mind?
Oh, they
Like, what are we dealing with here? What are these three letters for?
the angles.
Angles. So we should probably have angles in our justification. What's the math operation that you're seeing?
Addition.
Addition. So angle, addition, postulate maybe, which says that two angles, the part plus the part adds up to the total. Was that covered in class?
Yeah, we did that today.
Okay. And that does lead me to want to go back and change 9 and 10 now. I apologize there. Now that I see where this is going, I've got more clarity. So like 9, if we go back and look at 9, I was thinking something was missing, but the conclusion here is that EF plus FG equals EG. Okay. And what that is the segment addition postulate.
And what does postulate mean again?
Well, you may not be using that. Maybe you're using theorem. Postulate and theorems are kind of interchangeable. I want to say that they're the same, but you might want to check with your instructor, see if they're okay with it,
Because
because they're grading.
we used postulate today.
Okay. Don't get hung up on the words. Like you're going to remember the stuff in this class and you're never going to use it again. Even if you're a math person, like even if you go into like engineering or something like that, you're never going to need to know this, but um, it's a fine nuanced thing. Like what's the difference between a postulate and a theorem? I couldn't tell you without looking at the moment. So just use whatever your teacher wants in this case.
Okay.
All
Okay.
right. So that, and then we probably should update 10 now that I'm looking at it.
10?
Yeah. Because it's kind of the same thing. It's like, oh, the angles are the conclusion here is that the first angle adds up to the second angle. Like angle FED plus angle DEG equals angle FEG.
Okay. Then would that one also be angle addition postulate?
Exactly. So I think you're getting the hang of that part for sure.
Okay. Well, that's all I have for the first page.
All right, we got a couple minutes left. Is there anything else you'd like us to go over from, maybe from that other email or any other questions you got?
No, not really.
All right. So you guys, is your dad around? Because I was gonna let you know about some options for scheduling here. If not,